1.1 part that you need to know. Okay, just very fast, we go for here. Okay, what is chemical bond? Force of attraction that hold the atom together in a new species. Okay, so this normally we look at the valence electron. And then you must know what is Lewis symbol or Lewis dot symbol. So this depends on the group of the element. If we can identify the group of the element, we can assign the dot easily. So for example, lithium group 1, 1 dot. Here group 2 NS2, 2 dot. Group 13, 3 dot. Until group 18, 8 dot. Okay. Then, okay, you have to identify the group, period, or block of the element according to the valence electron. For example, this one, we have to look at the 3s1. This one, we have to check for the 4s2. This one, we have to identify 3s2, 3p4. So this is group 1, group 2, group 16. Because p block need to add 10. So this one, okay, group 15. This one, group 13. I think should be no problem for you all to identify the block and period. Because period, we check for the principal quantum number. Highest principal quantum, the highest one is the period. And then this is block P. So in this case, be careful, is 4s2, 4p6. This one is 3s2, 3p6. This one is 4s2, 4p5, group 17. Okay, just a short review. Okay, and then what is octet rules? 8 electrons around each to achieve normal gas electronic configuration. But for hydrogen, just triplet. And then we have to know how to achieve the octet rule. First, by transfer electron. Second, by sharing electron. Transfer electron is ionic bond. Sharing of electron is covalent bond. So there are 3 types of stability: noble gas, pseudo-noble gas, half-field orbital. So stability, first one, noble gas based on NS2 and P6. Pseudo-noble gas, NS2 and P6 ND10 or NS2 and P6 ND10 and F14. Half-field ND5. Okay, after that, okay, ionic bond. You must know the properties of ionic bond. Soluble in water, molten ionic, contact electric, high melting point, high boiling point, solid at room temperature. So when you form, right, okay, this one will form the cation, transfer electron to chlorine. So chlorine will become the anion. So after transfer, it becomes sodium cation. After it accept an electron, become chlorine anion, negative charge. Remember the charge. And then don't forget the 8 dot for the cation. Oh, sorry, anion. 8 dot for the anion, 8 dot for the anion, 8 dot for the anion. Must show the transformation of the electron for ionic bond. Okay. Next, if covalent bond sharing 1 or more pair. So there is no arrow, just show the sharing, okay, and then form a bonding. So here we call it as bonding pair. The rest over here, right, we call it as lone pair. So we must compare the strength of the single bond, double bond, and triple bond, and then the length of the single bond, double bond, and triple bond as well. So the strongest one is triple bond. Okay, the longest one is single bond. Maksudnya paling kuat triple bond, paling panjang single bond. Okay, then, okay, you must know what is formative bond. Formative bond is formed when one pair of provide 2 electron. Dia totally share sendiri je. Okay, dia share dua biji untuk membentukkan ikatan to form the bonding. Another one must have coordinate, have empty orbital to accept 2 electron. So lone pair, donor, empty orbital, acceptor. So these are the example: hydroxonium ion, ammonia, boron, chloride. Remember, must show, okay, these, okay, lone pair share to this electron, so form the coordinate bond, coordinate bond, must show. Oxygen ni membagi 2 electron bagi hydrogen. Okay, then next is about drawing restructure. Identify the central atom, count the valence electron, and then draw the bonding. This is the step. Okay. After that, we need to know what is formal charge. Using the total number of valence electron minus the total number of lone pair plus half times total number of bonding pair. Okay, based on the formal charge, right, we try to get the lowest one. Because if there are two Lewis structure, we will choose the lowest formal charge as the more stable structure. Okay, if there are three, okay, in this case, okay, besides we choose the lowest formal charge, we have to check, okay, this is negative, okay, this one and -1 for nitrogen, -1 for sulfur. So -1 should go to the located on the more electronegative atom. So it's nitrogen because nitrogen is more electronegative than sulfur. So this is about function of formal charge. Next is exception to octet rules, incomplete octet, expanded octet, or number octet. So I taught you all before, right? Incomplete less than 8 valence electron. What, for example, SN, beryllium, boron, aluminium, because electron deficiency species. Okay. And then expanded more than 8. Okay, non-metal atom of the third period onwards and due to the existence of MTD orbital. Odd number of electron. So for example, group 15, nitrogen, and then group 17, chlorine. Okay, next we need to know, after that, okay, we need to know how to draw the resonance structure. Resonance structure normally happen for the structure that have single double bond. This and this, both are the same. Both are correct. Okay, that's why for here, right, two or more possible Lewis structure can be written for certain molecule, but cannot neither one could accurate. It means both correct. So dotted line show the delocalized of electron. Another name for resonance. 2 is related with molecular shape and polarity. As I told you all before, right, we must know how to draw the Lewis structure, then only can proceed for molecular geometry and polarity. Molecular geometry and molecular shape is the same, huh? So in this part, we must know what is valence shell electron pair repulsion theory. Draw the basic molecular shape. The basic means linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Okay, if there is no lone pair, okay, the shape still the same. If there is lone pair, right, the shape and bond angle different already. After we successfully draw the molecular geometry, we can proceed, okay, to show the bond dipole and predict the dipole moment. Then only can deduce the polarity. So first, okay, molecular geometry is a 3D arrangement of atom in a molecule, affect physical and chemical properties. It's predicted by using the VSEPR model. What is EPR? VSEPR. It's an electron pair around the central atom will repel one another and arrange themselves as far apart as possible from each other. Why we need to arrange? Because we want to minimize the electron pair repulsion around the central atom. There are two types of electron pair around the central atom, bonding pair or lone pair. Okay, so this theory can predict the molecular shape, represent the lowest energy configuration of polyatomic ion and molecule. Okay, so always remember, highlight, double, triple bond counted as one bonding pair. Have the same effect on bond angle as a single bond. So there are three types of repulsion: bonding pair, lone pair, bonding pair, lone pair, lone pair. Okay, among these, lone pair is the strongest one. So the weakest one is the bonding pair, Okay, so this one I got you all before. So first you must identify the class of molecule. A is referred to central atom, B is referred to bonding pair, and the E is referred to lone pair. So next, total number of bonding electron and lone pair, right? We call it as electron pair arrangement. Electron pairs. So the electron pair arrangement is the name for the structure. If 2 linear, 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, 6 octahedral. Okay, and then the molecular shape have to check for the lone pair as well. So this one, linear. Okay, this one, trigonal planar as the basic shape. If there is one lone pair, we call it as V shape. The electron pair arrangement still trigonal planar, the shape is V shape. Initially is 120 degree. When there is a lone pair, less than 8. So type of repulsion, this one just bonding. This one bonding lone, bonding. Okay, if 4 tetrahedral, if there is 1, the molecular shape will change to trigonal pyramidal. But remember, electron pair arrangement still the same. And then for this one, V shape. Okay, so type of repulsion you can refer to here, bonding, 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 lone pair bonding, lone pair, lone pair, lone pair bonding, bonding, bonding. Okay, if there are 5, it's trigonal bipyramidal. 1 lone pair becomes seesaw. Okay, if 2 lone pair, AB3E2, T shape. AB2E3, linear. This is linear shape, T shape. When we assign the shape, right, we check for the molecular shape. This is like T, this is linear. Just now, this is trigonal bipyramidal, and this one square planar, seesaw, jongkang jongkek, seesaw, ataupun distorted tetrahedron. If there are 6 octahedral, 1 lone pair, square pyramidal, 2 lone pair, square planar. As I said before, right, the 5 basic geometry plus square planar with the same terminal atom confirm the dipole moment can cancel off each other because they are symmetry. So mu equal mu equal to 0. Sorry, mu equal to 0. So non-polar. That's why this is the step in drawing molecular shape. So you just follow everything. Start with restructure, assign. Okay. Check for this one. Effect of lone pair on molecular geometry. Lone pair of electrons are closer to the nucleus compared to bonding pair. Lone pair of electrons exert stronger repulsion on one another. That's why when there is a lone pair, right? So the lone pair will push the bond. That's why the bond angle will be smaller than the original one. So there's effect on the bond angle. Okay, check. Okay, among these 4, we compare. Initial is 109.5 for the tetrahedral CH4. But NH3 1 lone pair become 107.3. If there are 2 lone pair become 104.5. This is water. So when we answer the question, right, we can answer in table like this. First, you tell me, draw the restructure, and then tell me there are 4 electron pair arrangement, or is tetrahedral. Okay, 4 bonding pair. This is AB4, AB3E1, AB2E2. So type of repulsion for each other, and then the molecular shape of each of them, and then the bond angle. So you must explain this one. After that, you must explain about this one. Strength of the electron pair is like this. Okay. Okay. Effect of electronegativity towards bond angle. Just now is about lone pair. Now we talk about electronegativity. Higher electronegativity, stronger the attraction, the larger the bond angle. So for example, for this case, both of them AB2E2. 2 bonding pair, 2 lone pair. Why the bond angle for this one is smaller compared to this one? Okay, why? Because O is more electronegative than sulfur. So the bonding electron in OH are closer. So this one closer. Okay, that's why the bond angle of OH is larger than SH. Okay. Just now we talk about lone pair. Now we talk about electronegativity. FON. Fluorine is the most electronegative atom over the whole periodic table, followed by O and then N. Okay, so O is more electronegative. So OH bond are closer to O compared to the bonding pair in the SH. So repulsion between the OH is stronger, cause the bond larger. Take note, huh? So next compare. Okay, next about polarity. Okay, before I proceed for polarity, continue polarity. First of all, we must know what is polar bond, polar molecule, different electronegativity, asymmetry, and then positive and negative dipole can be distinguished. This is the key point to identify whether it is polar bond or polar molecule. Berbeza electronegativity means the positive negative berbeza. Electron letak pembahagian elektron pun berbeza. Next is about